So as we moved into the end of last week, we know that we have covered all of our topics in weather. We're now working on the culminating portion, the projects for this week that we'll end up doing, and you'll end up taking the test probably Friday as we move throughout the week. Sound good? All right. Air masses, fronts, and winds. Quick review of that for us here. Maybe. Now, we noticed when we took the benchmark that barometer seemed to show up more and more and more, and it was all of the things associated with the barometer as well, like high pressure and low pressure. And they interchanged, Raina, all of those things multiple times, whether it was like Billy noticed that the air pressure was getting lower, Susie noticed that the air pressure was getting higher, all of those different things, and then it asks you what type of weather occurs with that. So you have to know that a barometer measures air pressure. And if you look here, low air pressure, lousy weather and stormy and rain. High air pressure, clear, dry and cool. Sounds like that's what we're going through right now. I listened to the weather this morning, and they said it's going to be so clear and cool and windy that there's actually a danger of fire spreading if somebody were to be burning a fire. And then the wind caught some of those ashes and those moved away. And the ashes are rising because of what? Why are the ashes rising above a fire, Dawson? Because of convection, and then the wind carries those tiny little embers somewhere else. Right now things are dry enough in some places that it could start some fires in other places. So to be careful out there. Barometer. So that moves us into, not going to watch that. High pressure. H equals happy. We should remember that. Yes. Some of us are still not getting that, because you keep telling me that high pressure means it's hot and humid. That's not what the H stands for. Not once have we said that, other than when we're telling you that's the wrong thing to say. H equals happy. When you have high pressure, that means air is pushing down on you. If it's air pushing down on you, we know that cooler air is above us. The cool air is pushing down, and what that does is it pushes all of the other systems away from us. So you're not going to have fronts associated with high pressure, because it's going to be clear, cool, and sunny. Next one should be low pressure, I'm certain. There it is. L equals lousy. Now again, I know that a lot of people like rain. I know places need rain. And California certainly wouldn't be saying it was lousy if a low pressure system just sat over top of them for like 3 months. It's a way for us to remember. It's just a trick. When we say it's lousy, that means it's warmer, more humid air, and the chances of it raining are very high. And we've talked about all of the things that kind of cancels out. You're going to be inside if there's a low pressure system, because that's going to bring the fronts with it. Warm front. Every front brings what? Every front brings what, Jesse? Some type of precipitation. What type of precipitation it brings depends on the type of front. We know that warm fronts are very, very slow moving. What type of clouds form over top of warm fronts? What type of clouds form over top of warm fronts? Veda. Nimbostratus, because it is very light to moderate rain. Warm fronts can bring rain that might last a little longer, not as long as a stationary front, but it can last for a little while. Here's me going over another test question. Cold fronts seem to move a little bit faster. How do I know what direction any of the fronts are moving in? The cold front, warm front, any of those. How do I know what direction they're moving in, Fabiana?
There's like points or circles, like half circles to show.
Yeah, the symbols on the front of the front show you what direction it is traveling in. Therefore, if you're looking at a weather map, and you see a front is pointing towards North Carolina, you know that that front will make its way to North Carolina eventually, because that's the way that the front is moving. Cold fronts move a little bit faster. They throw that warm up in the air very quickly. And what type of clouds can you get with a cold front that are a little bit different than a warm front? What type of clouds can you get? The test is Friday. Wake up, people. I know it's Monday, but holy cow. Landon. Cumulonimbus, you get thunderstorms with cold fronts, right? Thunderstorms. Moving on. Stationary front. What's the trick to help us remember when we see stationary front, to help me remember what's going to happen, Sadie? It's going to stay in the area for a while. Stationary front. That's when a warm front and a cold front are kind of fighting against each other, seeing who can push who the furthest. And in between that is where those nimbostratus clouds form, and it rains for a few days on end. or a stationary front, not nimbostratus. Did I do? Nope, I skipped occluded front because we don't see that much. Somebody describe a sea breeze to me. What is a sea breeze, Mackie? A breeze that blows from the sea to the land. Why does the sea breeze happen? You have higher pressure over the ocean. The land heats up faster during the day. That hot air rises, causing a low pressure area. The cooler air with the higher pressure from the ocean sinks in to move that way, and you get your air moving from the sea to the land. Gee, I wonder what would be next. I didn't even do a question. Land breeze. What's going on with that? Why is that any different than a sea breeze? Because it's still at the ocean, it looks like. Maddox. That's right. And at nighttime, the land cools off very quickly, much faster than the ocean, which is kind of holds the temperature from that it absorbed during the day, the heat that it absorbed during the day. And what happens is now that you have a switch of high pressure and low pressure, the warmer air is rising over the ocean, causing a low pressure area to form, and the cooler air at the land is higher pressure. It moves in towards the ocean, and you have a land breeze. Moving on. We know that wind is the horizontal movement of air. What are some 2 reasons why wind actually blows? Like, it does this, and it does this because of this. There's 2 things. Nolan. Because of the unequal heating of the earth, what happens to cause wind to blow? It forms this and this. Brandon. The unequal heating of the Earth's surface causes high pressures and low pressures to form, and we know that wind moves from areas of high pressure to areas of low pressure. And you just told me that with sea breeze and land breeze. Everyone said in their definition, it moves from the higher pressure of the ocean to the land for a sea breeze, or it moves from the higher pressure from the land to the lower pressure of the ocean for a land breeze. You said that, so you kind of understand what's going on with this. Guarantee that unequal heating of the Earth's surface will show up. Why is latitude so important? And I didn't even have a slide for longitude in here, unless I have one later, but I probably didn't. Bobby?
Because, like, the equator is one of the lines.
The equator is one of the lines of latitude. How does that factor into that being very important, though, Landon? The equator gets warmer than anywhere else on Earth, so the closer you are in latitude to the equator, the warmer your temperatures are normally going to be. The farther away from the equator you get, the colder your temperatures are going to be. These mid-latitudes where we live, why is that so unique? What happens in the mid-latitudes that may not happen in all the places? You can in some of the places have some seasons, depending on where you are and where you're looking. You have some seasons in there, and it can get warmer in the summer and cooler in the winter. Prevailing westerlies. Why would I have made a slide about the prevailing westerlies, Sadie?
Because it moves weather across the United States.
It moves weather across the United States. If you don't think you're going to see a question about every single one of these slides, you would be wrong. Every one of them will end up on the test. And it's all the same stuff that we saw on the benchmark and have reviewed already. Not watching study jams, not watching that one either. We can watch that later. Ooh, I need to go back and find out what that was to figure out why it got deleted. And we're going to move on from that. El Nino, La Nina. I don't need to dig super deep into this. Briefly describe El Nino and why it is an important factor in global weather. Man, it's the same people. The rest of y'all sleep or you don't know the answer. Anna. The water in the Pacific gets warmer. How does that change weather in some of the places in the world? What's it do for us, per se, in North Carolina? It does cause us to have a rise in precipitation. So much so, in some of these places, you can actually start getting floods. It does have an increase for North Carolina and some parts of the U.S., an increase in temperatures, which means summers and winters tend to be warmer during the El Nino season. You are correct. What about a La Nina? How is that going to be a little bit different? Yes, I know, it's funny. La Nina, how is that different? Judah. The water in the Pacific cools. What does that do to the weather in North Carolina? Decrease in precipitation. And what's that one thing that we mentioned that was like really important to look at, especially, I mean, right now we're in a La Nina season. What might happen to us, Shayla? Larger risk of hurricanes forming during hurricane season. So this fall, when hurricane season rolls around, we really do, especially if you're a weather person, you got to keep your eye out on the Atlantic Ocean to see if any of those tropical storms start forming into hurricanes, because it is a more active hurricane season for us. Okay, I'm going to move on from that. And so we know that jet stream questions pop up every once in a while, and one of the questions I know they're going to ask is, what is the air mass above the jet stream, and what is the air mass below the jet stream? Hayden. Above the jet stream is cold, below the jet stream is warm. Now here's where people kind of get this a little confused. It won't show you a picture. It will just say the jet stream moves north of North Carolina. What kind of weather happens? And you have to think about that. What would happen to North Carolina if the jet stream moved north of us? Landon. That's right, because that means the jet stream is above us and it would get warmer. If the jet stream moves south of North Carolina, we're going to get what, Dawson? A little cooler, because you're going to get the, now if it dips super south, like it when it goes down to Florida, we get that really cold polar vortex. And we've seen that, that's like we've talked about when we were out of school for a week there, or at least delayed for a week, because the buses wouldn't even start. It was so cold. What can the jet stream do that's also very important? It has something to do with the prevailing westerlies. Maddox. It can deflect the weather that's moving across the United States. You are correct. Again, we've seen those questions. Also, remember that Great Lakes question that we covered, where the jet stream was above and below the Great Lakes? If you have a question and you're not too sure where the place is, please ask. I can show you the place. I just can't tell you what the answer is, but you should be able to figure that out. Moving on here, Gulfstream. Why is the Gulfstream important, and what does it do that's different? Shayla. It is a very, very warm ocean current that forms in the Gulf of Mexico. What does it do to the places it surrounds, Jesse? It warms England up. England should have a climate a little closer to upper Canada, but it doesn't. It can be cool in England. It can snow, but it's not like that because the Gulf Stream runs nearby it, and it causes it to warm up and keep that climate a little bit more moderate, which is the same thing it does for our coast. And it also keeps Florida a little bit warmer. Florida's lucky because they're also a little closer to the equator as well. Gulf Stream, very important thing to remember. And let's see, hurricanes. What are some facts about hurricanes? How do they form? What do they do? Why are they dangerous? Sadie.
There's something that happens with a hurricane. It's called storm surge.
Yeah, the storm surge. Tell me about that.
Water. It's when breezes from the hurricane blows water up on land.
The hurricane literally brings the ocean inland, doesn't it? It is very dangerous. Remember the video that we watched? Very, very dangerous. And again, you don't have to worry about that if you're like at the beach in July, like you're just there. Like if they say there's a hurricane warning, like then it's time to leave. Like you don't want to stay unless you're like those guys that want to hang out in the hotel and film everything. But I don't think anybody in here is ready to do that. What else about hurricanes, Judah? The eye is the calmest part. Jesse? That's what you're going to say, Dawson? So one last important thing about hurricanes is they need warm water to help feed them, right? The more warm water, the more evaporation you have, the more water that can go up into the clouds, and it causes the storm to be more powerful. So when it does come on land, those high winds and rains that we all know about come inland, but it also brings that storm surge with it, and that's what makes hurricanes so dangerous. But I know for a fact they're going to ask you where do they form, and it's over warm ocean water, not over a lake, not over land. They're going to form over warm ocean waters. We will pause.